And we're back. Good evening, everybody, and welcome to this evening's safety workshop on traffic pattern operations, specifically at non-tower airports. My name is Brian Combs. I'm the marketing and safety manager at the Bowling Green Flight Center. For some of you who maybe are not familiar with the Bowling Green Flight Center, we are the official flight training provider for Bowling Green State University's aviation program. Usually on an annual basis, we're flight training somewhere between 300 350 flight students. With a large flight training operation, we do have a robust safety program, and part of that safety program is an anonymous safety reporting system where we have students and employees collect reports throughout the entire year as it relates to our operations. We look at that data, we look at trends, and we do develop trends, we do see trends happening, and we have a lot of tools in our toolbox to address those trends. And one of those trends is having roundtable discussions or talking about those trends in meetings, or even hosting something like a safety workshop, which we're doing tonight. So tonight's safety workshop is based on trends that we have seen within our operation here in Bowling Green, Ohio. However, the trends that we see at BGSU are not exclusive to BGSU. Talking to other pilots that are in the aviation community, we know that these trends exist elsewhere. So we're happy that you're joining us tonight as we focus on traffic pattern operations. This is number 2 safety workshop that we've done. We did one earlier in the spring. That one was on loss and separation. It is recorded a little bit later on, maybe towards the end I'll drop a link so you can look at the recording of that if you're interested. The idea is to continue these safety workshops into the future. Future topic to be determined, but we would imagine the next workshop sometime in the fall timeframe, which for us would be somewhere between September and November. So be on the lookout for future communications on additional opportunities where we can join in on a collaborative conversation down the road. So with all that being said, I'm going to hand it over to our chief flight instructor here at Bowling Green State University, Catherine Smith.
Hello and welcome to our safety series. We're really excited to be able to share this topic with you tonight. And my job today is to just invite you into getting to know our presenter, which is Ethan Beagle. He is actually an employee at the Bowling Green Flight Center and an alumnus of Bowling Green State University. He graduated with an undergraduate degree from BGSU and began working at the Bowling Green Flight Center in 2017. He since moved into the rank of certificated flight instructor, instrument instructor, multi-engine instructor, and then most recently in 2020 became a Part 141 Assistant Chief Instructor. So without further ado, Ethan Beagle.
Hi everybody, thank you so much for joining us tonight. Let's talk about traffic pattern operations. I'm very thankful to have this opportunity to lead this workshop and to just go over some information that may benefit all of us in the aviation community and make our skies safer for everybody. Like Catherine said, I am Ethan Beagle. I'm a 141 Assistant Chief Instructor at BGSU. In that role, I've had a really great opportunity being able to instruct alongside a lot of my peers, and now I get to see the more evaluation side of it and the more technical side of it, which I absolutely love. Along with that is this great opportunity to talk about traffic patterns and operations within those traffic patterns. For today's presentation, we're going to talk about a few of the objectives that we're going to cover as we go through this presentation. The first one, where we're going to review traffic pattern operations, general traffic pattern layout, entries, and how we deal with traffic pattern, aircraft in the traffic pattern, excuse me. We're also going to evaluate 2 case studies that happened here at Wood County Airport. Like Brian Combs said, we are going to primarily focus on operations here at the Wood County Airport and within BGSU. These case studies were pulled from our SMS reporting system that Brian talked about earlier, and they will remain anonymous for the people involved. After that, we'll kind of discuss some of the strategies for aircraft spacing and collision avoidance inside that traffic pattern, especially in congestion and when radio presence is extremely heavy. Lastly, we'll field any questions and feedback that we might have from the community, from the aviation community. I know a majority of our attendees today are from outside of the Bowling Green Airport BGSU Aviation Studies, and so we'd love to hear your feedback and any other topics you might want to talk about in today's discussion. Lastly, I just want to show you the resources where I pulled a lot of my information from today. The PHAC, Pilot's Handbook of Aeronautical Knowledge, and then AC 9066B is about traffic pattern operations in non-towered airports, and that's what we'll be talking about a lot today. So first thing first, let's talk about traffic pattern operations and traffic pattern layouts to begin. So right now we have an aircraft holding short of runway 10. This is the airport diagram for Wood County Airport. We have runway 1028 and runway 18 and 36. 1028 being our primary calm wind runway. In today's scenario, we're going to be departing runway 10. So you can see the aircraft has departed runway 10 and they're on that departure leg. This is where the aircraft is going to be climbing and gaining altitude while remaining in the traffic pattern. Next, at about 300 feet below our traffic pattern altitude, we turn to our crosswind leg. As we turn into our crosswind leg, the aircraft is reaching our traffic pattern altitude and beginning that cruise phase. Once the aircraft is cruised out, we then turn our downwind leg and we parallel that runway that we took off of, runway 10 today. And the aircraft is going to continue downwind. The ground speed is going to be the fastest. This is where we're making our wind correction to remain within a couple miles of the airport itself. When the aircraft is on downwind, you can prepare your aircraft for landing, configure however you may be, whether that's running your landing checklist, extending the landing gear if you have a retractable landing gear airplane, and then finally configuring just for that stabilized approach to landing. Once the aircraft is about 45 degrees from that landing threshold, we'll turn our base leg. That base leg is where that descent to landing is accomplished, and we'll continue that turn to final, where the aircraft is hopefully making that stabilized approach to landing and finally landing at the airport. A couple of other terms that we're going to throw out there today is upwind. Upwind leg is a lot of times confused with the departure leg. The departure leg is the leg immediately after the airplane has taken off of the runway, whereas the upwind leg is accomplished if the aircraft is doing a low approach, a go around, or a sidestep off of an instrument approach procedure. And they're kind of sidestepping and paralleling that runway. And lastly, the last term that we'll talk about here and we'll use in our case studies is the 45-degree entry to downwind. So the FAA talks about how, and we'll cover this a little bit later, the FAA talks about overflying the aircraft, overflying the airfield in your aircraft about 800 to 1,000 feet above traffic pattern altitude to allow adequate spacing between those aircraft that might be already established in the traffic pattern. As the aircraft overflies, you're taking note of other aircraft inside of the traffic pattern, making a call that you're over top of the runway, and accomplishing any other checklists you may need to complete. After that, as we turn for runway 10 in today's scenario, we'll make a right turn as we join that 45-degree downwind. See the aircraft turning there, and then initially joining the downwind leg of the traffic pattern. On this 45 to downwind, or even once you join the downwind leg, this is again where you will be accomplishing your landing checklist and any other checklist items that you need to complete a stabilized approach to land. Next, we're going to move into our case studies. So we have two main case studies that we're going to cover today. The first case study having a part A and a part B. There were two incidents that kind of happened in the same flight with the same solo pilot, and we'll cover both of those scenarios and talk about the similarities. This first case study happened when there were multiple aircraft in the pattern for runway 28. And for today's scenario, runway 28 is right traffic pattern here at Wood County for noise abatement procedures over the city of Bowling Green. At the time, all the aircraft were making proper position reports. Now, aircraft A, I have labeled, it was a dual training event. It was a student pilot with another instructor who were completing laps in the pattern for a traffic pattern lesson inside of our curriculum. And aircraft B was a solo instrument student. So a student pilot who had already been private pilot certificated is now working towards the experience requirements for the instrument rating. Aircraft A extended their departure leg to create more spacing behind the aircraft on downwind. Now, this is a strategy for separation that we'll talk about a little bit later on, And this aircraft actually accomplished that strategy to create spacing beside or between that unlabeled aircraft that was already established on the downwind. When the aircraft turned crosswind, the the private pilot who was solo inside of aircraft B turned crosswind off of a touch and go in front of aircraft A. So they were not aware of that aircraft already on an extended downwind. And finally, that aircraft A had to execute a 360-degree turn to the left to avoid collision with aircraft B, and aircraft B continued on their downwind leg behind the other aircraft that was already established, kind of not really knowing what had happened inside of that traffic pattern at that moment. Now, later on in that same flight, the same student, aircraft B, had another situation where there was an aircraft inbound on the RNAV approach. So in the same scenario, there were multiple aircraft inside of the traffic pattern, again, right traffic pattern, and they were all making radio calls. Now that comes into play here a little bit later with heavy radio presence. Aircraft Charlie was a dual training event. So this training event was an instrument student working toward instrument experience, executing the RNAV 2.8 approach in those visual meteorological conditions. So they were VMC, they saw other traffic, and they made proper radio reports on the way inbound from the approach. As Aircraft Charlie called about a 2.5-mile final, Aircraft Bravo turned base in front of Aircraft Charlie. Aircraft Charlie said, "Hey, do you see us?" Aircraft Bravo said, "Yeah, I see you. I'm going to continue my base to final," even though it was a little bit tight for comfortability. So finally, Aircraft B continued to turn final, and Aircraft Charlie had to slow down on the approach to make sure that there was safe spacing, and ultimately did a go around to avoid a runway incursion, 2 aircraft on the runway at the same time. Now, some of the highlights that we take away from that case study are that there were multiple aircraft in the traffic pattern for runway 28 at the time. Multiple students, multiple instructors, all completing traffic pattern, whether it be at the end of a flight training event, at the beginning of a flight training event, or during their training event, accomplishing those takeoffs and landings. Another thing was the CTAF was busy. That common traffic advisory frequency was busy. There were a lot of people making those radio calls, and sometimes people were stepping on each other and not getting the communication through that they needed to. Another big factor was this student was solo. So the task load on top of this, or for the student, was higher than normal, higher than if a CFI had been on board the aircraft with them, or even just another safety pilot. The student was responsible for checklist usage, flying the airplane, making those radio calls, and scanning for traffic all at the same time. So very task saturated. And finally, that task saturation led to a lack of situational awareness. That private pilot inside that aircraft was not aware of other aircraft positions inside the traffic pattern. And then radio awareness, those traffic pattern, or the aircraft in the traffic pattern making radio calls, didn't quite click to the student as to where their position was in relation to those. As we move on to traffic or case study number 2, you'll notice a lot of similarities between the two, which we'll cover in a few minutes as well. So again, there were multiple aircraft in the traffic pattern for runway 28, right traffic pattern, all making those proper radio calls. Aircraft Delta was a dual training event, again accomplishing a traffic pattern lesson, a private pilot student pilot. Aircraft Echo was a solo student pilot who was accomplishing and finishing up their very first solo cross country. So their very first time ever leaving 1 Golf 0, and this is their entry back into the airport after that flight. Aircraft Echo made position reports while they were about 10 miles to the south of the field, announcing their intentions to join a 45-degree downwind after overflying the field at 2,500 MSL. Very common entry to the runway, and we'll talk about that in a few minutes as well. And the student did everything right up until that point. Now, once the aircraft was on a downwind at a midfield, Aircraft Echo executed that 45-degree entry directly in front of Aircraft Delta. And that resulted in Aircraft Delta having to make an immediate left turn to the north and departing the traffic pattern, while Aircraft Echo continued on their downwind. So a lot of similarities between those first 2 case studies. Highlights of case study number 2, again, multiple aircraft inside the traffic pattern for runway 28. Multiple aircraft lead to a busy CTAF frequency. position reports, aircraft crossing runways on the ground, the CTAF frequency was saturated, and that maybe led to a saturation of the radios and then a lack of situational awareness. This time, the solo was a student pilot, so very first time outside of the traffic pattern. And again, that student pilot doesn't quite have the experience level of the private pilot student in our first scenario. Ultimately, that led to a lack of situational awareness, again, of aircraft position and what radio calls meant what for aircraft position inside of the traffic pattern. So these two case studies together have a lot of similarities. I've mentioned that a few times now. Some of the main similarities between the two flights are that we had a congested traffic pattern at a non-towered airport. At a towered airport, you've got a controller who is able to separate traffic, maybe send traffic two different directions, establish two different traffic patterns. Here at Wood County, we don't have the luxury of having control. And so a lot of the see and avoid that traffic pattern maintenance and aircraft spacing is left to the pilot themselves, which can lead to a congested traffic pattern. As I've mentioned before, a congested traffic pattern leads to a very congested common traffic advisory frequency. A lot of calls on the radios, aircraft crossing runways on the ground, aircraft announcing their intentions while they're 10, 15 miles out, can all lead to very heavy radio communications. Solo pilot operations are a big one between these two. Those solo pilot operations lead to heavy task saturation while the student is trying to fly the aircraft, run checklists, look for traffic, and make their intentions known on the frequency as well. And then finally, a lack of situational awareness. A misunderstanding of aircraft based on position reports is key into both of these scenarios. And we'll talk about a couple of strategies on how we can prevent this congestion, how we can prevent misunderstanding of where aircraft are going to be in the traffic pattern, and we'll move on to that next. So prevention strategies. How can we make sure that traffic patterns are staying safe? First off, we can standardize how we enter traffic patterns. I'll talk about this one in a few minutes as well. The FAA does standardize how we enter the traffic pattern, how we make the calls that we're entering the traffic pattern. But if we standardize them to where everybody knows exactly how we're entering the traffic pattern, it'll make more situational awareness of where those aircraft are going to be located while they're not inside of the traffic pattern, but while they're entering. Next off, we'll talk about extending the departure leg to allow more spacing between those aircraft. Radio communications are key when it comes to situational awareness of where aircraft are located in the traffic pattern. We'll talk about a few strategies for that one as well. We can talk about how ADS-B in and traffic advisory alerts inside of your aircraft can be very helpful, but can also be harmful in some scenarios. And finally, we'll talk about how in instrument flight rules, an aircraft on an IFR flight plan or maybe in IFR, and executing practice instrument approaches can change the way that they're doing their approach while they're in VMC to accommodate for other VFR traffic inside of that traffic pattern. And ultimately, you can always exit the traffic pattern and re-enter it when it's less congested. Depart off the downwind, climb over the field, go out to the practice areas, and come back to accomplish those landings at a later time, or ultimately go to another airport. So when we break down each of these strategies, they all have their own kind of characteristics on what we can do as pilots to make sure that the safety inside of our traffic patterns is maintained. Now, when we talk about traffic pattern entries, the FAA does encourage overflying the airfield and entering a 45-degree downwind. This comes straight out of AC Advisory Circular 9066B. Has a couple of different ways that you can enter the traffic pattern, the most common being overflying the field approximately 800 to 1,000 feet above traffic pattern altitude, executing a teardrop turn and entering the downwind on a 45. If we standardize where that entry puts an aircraft on downwind, it gives aircraft inside of the traffic pattern already established or those wanting to depart and enter the traffic pattern from the runway on the ground a better idea of where to visually scan for that traffic and knowing exactly where to look for them. In a training environment like 1 Golf 0, that longer downwind, if we enter the downwind like the picture on the left side there, if we enter the downwind towards the departure end of the runway, It gives the aircraft more time to complete checklists, visual scanning, and overall decision-making leading up to that stabilized approach to landing because, go back there for a second. Because if you look at the picture on the right where we enter a midfield 45-degree downwind, that downwind leg that we have is extremely shorter than the picture on the left. And then the student pilot, especially if they're solo, is more rushed to get checklists done, to visually scan for other traffic, and to allow them to have that visual stabilized approach to landing. Now, for aircraft on the ground, when they're looking out to the north of the airfield, the south of the airfield, where they may be looking for that traffic to enter the traffic pattern, if they know exactly that they're coming towards the departure end of the runway, they can turn their eyes to that area and have a better idea of where that aircraft is going to be coming from, and ultimately knowing how much time they have to depart and establish themselves in the traffic pattern as well. Now, earlier I talked about extending the departure leg. This is a common practice here at BGSU and our SOPs, and a lot of the other aircraft that fly in and out of 1 Golf 0 have taken onto this practice as well. And so this is something that we're encouraging all G8 aircraft to consider whenever the traffic pattern is congested. When you extend that departure leg, so you climb up to traffic pattern altitude before turning, or you climb up to traffic pattern altitude and then extend your departure by a few more miles or a couple thousand yards, however much you may want it to be, it allows that greater spacing between the aircraft inside the traffic pattern. You can see in my picture here, if my aircraft that's on the departure leg right now would have turned a normal crosswind, they would be turning into the aircraft that was already established on the downwind, and the spacing would be less. Like I said earlier with the entry, when the downwind leg becomes longer, it allows more time for checklist usage, communications, visual scanning, instruction when you're in a flight instruction environment, and then aeronautical decision making. When we think about solo student pilots, again, we want to give them space. They might not have the same experience level as a commercial pilot applicant or a CFI applicant or someone who's been in the industry for many, many years. When we give them more time on the downwind, it's allowing them to complete those checklists, make their radio communications, and visually scan for that traffic that might be in the traffic pattern. By not task saturating these student pilots or any pilot in general, it's going to allow for them to set themselves up for a stabilized approach to landing. And like I said here, that longer downwind creates a more stabilized approach. When we have a faulty approach, it's going to lead to a faulty landing. We don't want to have aircraft accidents on final approach to landing. We want to make sure that all aircraft are stabilized on their approach to landing. Ultimately, when you're extending the departure leg, you can also execute a 360-degree turn on the downwind if necessary. In our very first case study 1A, the aircraft, that was a dual training event, completed that 360-degree turn to the left off of the downwind in order to avoid a collision hazard with that student that was solo. And finally, though it's not the most ideal, we can slow the aircraft down to a slower cruise speed or configure the aircraft a little bit early to allow us to gain greater spacing between the two aircraft on downwind, or three if there's even that. Again, not ideal. We don't want to put the aircraft in a configuration too early that might fault that stabilized approach to landing. Radio communications. The radios are how we communicate. We don't have ATC to direct us when we're at an uncontrolled field, so we have to be ATC ourselves. And so by making sure that our radio communications are efficient and clear and concise for exactly what we want them to be, we can act as ATC kind of ourselves. The first thing in the major practice that we have here at BG, and actually I've heard many other places, is announcing that you're a solo student pilot. That solo student pilot lets other pilots know, it infers that that pilot is at a different experience level than others. That solo student pilot doesn't have the skills that a commercial pilot may have. They might take a little bit longer on their departure, on their checklist usage, and their visual scanning might not be quite where the rest of the industry is going to be. So making that announcement tells us, as more experienced pilots, that we can give them a little bit more time, or we can offer our guidance to them as well. The FAA recommends making position reports within 10 miles of an airport. If you are getting flight following, or if you're on an instrument flight plan, which we'll talk about in a little bit as well, making sure that you're announcing your intentions at least 10 miles away from that uncontrolled airport lets other aircraft in the vicinity or already established in the traffic pattern know what your intentions are going to be and where you're coming from, and so they can look for you and kind of establish their plan for dealing with you coming into the pattern. With position reports, we want to make sure that we're not over-reporting. We don't want to say we're on a 10-mile final, 8, 6, 4, 3, 2, 1. We're only taking up valuable airtime on that frequency where other people can be announcing, I've got the inbound traffic in sight, I'm executing a left 360 for spacing, or I'm a solo student pilot. We don't want to inhibit others from making position reports when they're inside of that traffic pattern. When you make your position reports, announcing your aircraft type and speed definitely helps with decision making when it comes to other pilots. If I announce that I'm a Cessna 152 on a 10-mile final, that tells me as a student holding short of runway whatever we're departing from, that I'm going to have plenty of time to take off. But if I announce that I'm a TBM or a PC-12 or a citation jet inbound on a 10-mile final, I know that their closure rate, their speed on final is going to be a lot greater, and my time to depart is going to be less. Ground reference points can be very helpful. However, these are really only pertinent to local pilots. If I am primarily flying out of 1 Golf 0, and I say I'm a beam in the water tower on the downwind for runway 28, someone who is from out of state, just a transient traffic, might not know what we're kind of basing our location on. So these can be really helpful. However, we don't want to rely on those for those transient traffic or someone who's not familiar with the area. When you're in a training environment, you want to make sure that students practice their communication and they have that comfortability on the radio. As a CFI myself, I often find myself just jumping on the radios, and especially with ATC, getting those clear and concise calls to kind of save some time on the radios and let my student focus on flying the airplane. That's a good practice to let your student fly the airplane. However, that student needs to have that comfortability for when they complete those solo operations and know what they're going to say on the radios, how they're going to say it, and ultimately have the confidence to say and understand what other pilots are saying on the radio as well. Again, we can use real dialogue when needed. Radios, they have etiquette, we have terms, we have phrases that we use. Ultimately, just talk. Everybody's human, and we can say, hey, aircraft on base, I don't quite understand what color you are. Can you tell me maybe a ground reference point that you see? Are you over 75? Using that people talk just allows you to have a connection and have a better understanding for someone, especially who may not have that communication phraseology quite down, especially solo student pilots. When we're on the traffic pattern, announcing aircraft closure rates and configurations can be very helpful for decision making as well. Ground speed callouts. Hey, I'm on a 10-mile final, but I'm only doing 80 knots across the ground. Again, gives the same indication of announcing your type of aircraft and a better idea of when someone can depart that runway. In a training environment, we are all often executing simulated single engine approaches, simulated single engine patterns, or power off 180 accuracy approaches in the traffic pattern. When we announce these intentions or we announce these configurations, it lets people inside the pattern, lets other pilots inside the pattern know that we may be in a simulated emergency scenario. They can give us more space, or that we're going to be operating a little bit slower and give them more spacing inside that traffic pattern. ADS-B and equipment. So back in January of 2020, the FAA mandated that all ADS-B out, that all aircraft be compliant with ADS-B out in certain situations. And so with ADS-B out comes ADS-B in. A lot of newer aircraft, especially our G1000 aircraft or our G650, or even some of the 430 aircraft that we have, are equipped with that traffic information in. And that can be really helpful. However, it is not a replacement for see and avoid. You can't rely on that traffic information to tell you exactly where that traffic is going to be. And you as a pilot still have to look outside and find that traffic. If you want to keep your eyes outside, again, traffic is helpful, but it's never going to be that indication, or sorry, that reliance on there. It's helpful for your situation awareness. Before you depart the runway, taking a look at the traffic page, something that I do as a CFI, just take a quick look at the traffic page, make sure there's no one inbound on any approaches that I maybe missed their radio call. This helps me kind of get an awareness of what other aircraft are in the vicinity, and so I know who to be looking for whenever I do get airborne. And once again, it's a good supplement, but not all aircraft are equipped with ADS-B out. A lot of times, if you're operating at an uncontrolled airport, those aircraft, you get your Piper Cub or your Stearman biplane, something that's not going to have that electrical system that supplements a ADS-B out scenario. They're not going to have that equipment, so therefore they're not going to show up on your traffic page. We don't have onboard radar the way that ATC does, and so we still have to keep our eyes peeled outside and looking for that other traffic. The next thing we're going to talk about is IFR traffic that's completing practice instrument approaches in VMC. Or you don't even have to be IFR to be practicing approaches. So a lot of the things that I say on this slide have to do with radio communications. And this is key if you're transitioning from an instrument flight plan and you're getting handed off to your common traffic advisory frequency. Making those position reports early is going to be key to allowing someone to establish that situation awareness of where the traffic is going to be entering the pattern from. Again, announcing your aircraft configuration. I'm a multi-engine aircraft doing a simulated single engine approach is going to give an indication that you're going to be flying across the ground at a slower ground speed, and you might be more task saturated trying to complete checklists and stuff like that, and your traffic awareness might go down a little bit. You want to announce your goal of the instrument approach procedure. Are you circling? Are you a low approach? Or are you sidestepping? Again, we're painting a very well-painted mental picture for the other aircraft in the pattern. We want to make sure that we are letting them know what our intentions are so that they can plan and we can plan for them as well. This is key when we're talking about separation, what runway we're using, especially at an uncontrolled airport where there's not a runway in use. If I'm coming inbound on a opposite direction approach of the runway in use, I'm going to say, hey, I'm going to break off on a 3-mile final or a 2-mile final and join the traffic pattern. The next point is we want to adhere to those local traffic patterns as well. The FAA has come out with some guidance recently that says overflying an airfield and joining the local traffic pattern off of an instrument approach when there are other VFR traffic in the vicinity is going to be your best practice. It's going to make sure that we are adhering to local traffic pattern layouts and that we're joining that flow of VFR traffic and not disrupting something that's already established. If we're circling off of an approach, we also want to make sure that we're circling in the direction of that traffic pattern. For example, runway 10, if we're circling to runway 28, we do have right traffic pattern for runway 28. I'm going to sidestep to the left of runway 10 and join that VFR traffic pattern for runway 28. Granted, I will be at lower minimums. I'll be about 400 to 500 feet below that standard traffic pattern altitude. And I want to make sure that I'm announcing that to those who are in the traffic pattern as well, so they know to look at a lower altitude for me. If you're in VMC, an IFR traffic or an aircraft on an IFR flight plan has no priority over other aircraft. You're in VMC, and in VMC conditions, see and avoid takes precedence. Aircraft right of way takes precedence. So you, as an IFR pilot, have to be looking for that VFR traffic, and you, as a VFR pilot, have to be looking for that IFR traffic, especially when we might be on a marginal day where you have aircraft completing traffic pattern, but you might have an instrument approach coming in that might pop out of the clouds or descend below the cloud deck as they reach the traffic pattern area. So we want to make sure that we are looking for that traffic. So when we look at all of this together, we want to make sure that we have a few takeaways. What are the practices that we can take away from today's discussion and take back with us to our airports? The first thing, we want to make sure that we are definitely situational aware of other aircraft in the traffic pattern. When there are multiple aircraft in the pattern, it can lead to congestion. It can lead to heavy radio presence, and then it leads to that lack of separation. Our last safety series talked about that loss of separation, and one of the worst places to have that loss of separation is inside of a traffic pattern. We have a lot of aircraft that are flying slow, but we all have the common goal of making a landing at that runway. So if it means that we have to depart and come back a little bit later, ultimately the safety is the same goal. Safety is the same goal of all of us while we're at airports. Especially at general aviation airports, there's going to be a high volume of flight training. And this can lead to very different levels and very many different levels of pilot experience. Here at BGSU, we take someone who has 0 flight experience and we take them all the way up to a CFI that has 1,000 hours or 2,000 hours. Or we have that airline transport pilot that's coming in and doing their currency in their Cessna 172, who has thousands and thousands and thousands of hours and all this experience. When we take all of those different experience levels and we mash them together, we want to make sure that, again, we're all working towards that same goal of that safe and compliant traffic pattern. Finally, a lack of situation awareness can be both radio communications and aircraft position in the traffic pattern. I've mentioned this a few times throughout, but if you don't have an understanding of those radio communications inside the traffic pattern, you're not going to have an understanding of where that aircraft is located. And so using things like standardizing that traffic pattern entry and looking at our ADS-B in, if we're equipped, helps us establish where that traffic is going to be. Also, just taking a few seconds when we check onto the frequency to kind of listen for who all is going to be in the pattern and establishing that mental picture of where they're going to be in the pattern is key. One of these case studies actually involved one of my students that I sent out solo. And when we did this remedial training, I took the student outside and we just sat in an airplane and we just talked. And we turned on the airplane and we turned the traffic page on and we let the GPS get its signal. And we just sat there and we listened to the radio and we looked at the traffic page and we put together kind of like a puzzle of, okay, this aircraft called downwind. Where can I see him? This aircraft is called departing runway 28. Where should I expect to see them? So when we build this situational awareness and we take all of these things that we've talked about today, that helps us build that mental picture of how things are going to go, and then ultimately lets us be prepared for when something doesn't quite go our way. You know, as we look outside, we look at our traffic, we might not see the aircraft that was below us, but when we take our time and we accomplish our checklist on an extended downwind, or we make sure that we're making radio calls 10 miles out, it gives us time to look for that other traffic who may not be reporting where they're at. Lastly, again, I just want to give you my resources on where I got my information so you can read up, brush up if you want. The PHAC is a great resource for any pilot. I highly recommend just brushing through it every once in a while. And ultimately, that FAA Advisory Circular 9066B is specifically titled Aircraft Operations at Airports Without an Operating Control Tower. So it gives a lot of guidance on how we as general aviation pilots can have that guidance to get into traffic patterns and make that difference and make that safety and compliance. For those of you who are in attendance for the Wings credit, at this time, please type your full name into the Zoom chat feature that Brian talked about a little bit earlier, and we'll forward those names of those in attendance to the FAST team, and you'll receive that Wings credit. At this time, if you also want to type any questions you may have into the chat, Catherine and I would be very happy to answer any of those questions. And ultimately, thank you for attending, but we will field some of those questions and feedback from the community now.
So I apologize earlier when we were doing introductions, I was talking, or our chief flight instructor was talking. This is a new room to us. The mic is actually right up here and not over there where we were talking. So sorry if you couldn't hear us in the start. We're learning as we go. We'll improve on that for future safety workshops. So I am going to be looking at the chat here. I'll be reading off questions to both Catherine Smith and Ethan Beagle here for them to answer or kind of respond to. So just give me a minute here. So the first question I see from Wayland, if flying practice IFR approaches, should you be at VFR altitudes?
That's a great question. I'm actually I'll let Kathy take this one. This is something that we've talked about a ton here in our training at VGSU, and I think it's a wonderful question.
Okay, so I think the question was, if you're flying practice approaches, should you be at VFR or IFR altitudes? So I think we need to get into terminology. Are we talking about we're operating in VMC, visual meteorological conditions, and we're doing approaches, maybe just practicing on our own, we're simulating our own air traffic control clearances in the cockpit. And in that case, I think we would want to be using VFR altitudes. If we look at training someone to operate in the instrument flight rules environment, whether or not we're trying to do it in visual conditions or instrument conditions, we really do need to simulate training that according to the approach plate, the arrival procedure, the departure procedure. So we do need to standardize and actually get the student to get the experience of the plate. So this is a catch-22. So one of our strategies, because we are at an uncontrolled airport and in our local area, Wood County, is when we are operating with, say, Toledo approach, typically we will be on the published altitudes of the instrument approach procedure. If I'm not going to work with Toledo that day and I'm going to do the ATC function myself for my student, and I may stack myself a couple, 200, 300, 400 feet higher than the published plate, so that I know that I have separation if somebody else is doing the exact same thing I'm doing, which is trying to run the plate without air traffic control on a visual day in a local environment. So I think there's probably no one-size-fits-all answer to this question. I think both scenarios require vigilance. I know that we had 2 loss of separations that actually we highlighted in our previous series, where we had students with air traffic control on an instrument approach procedure, and the transient, the other aircraft, was not with ATC, and they actually had a loss of separation. The one that happened down in Findlay, the Seminole pilot broke off because they saw the other incoming pilots, and so they did their own separation. And then the one that happened up at Wood County recently, right after that, was Toledo was working the flight on the RNAV-28, and we had another pilot who wasn't with ATC, and Toledo called that break off of that procedure to keep separation. So I don't think there's a one size fits all. I do think that if you're in visual meteorological conditions, you do have to pay attention to what else is going on around you. If you're trying to operate on instrument flight rules in visual conditions, I think it adds another layer of dimension, because you're trying to run the plate, but you also have to keep in mind the visual traffic around you, which could be running VFR, cruising altitudes across countries, or, as we said, in the traffic pattern as well. So there's probably not one prescriptive answer to that.
So next question comes from Mark. When I'm in the pattern, I always announce my aircraft type, but I don't often announce my tail number. I'll say Anytown traffic, Cessna Cardinal, left midfield, downwind, runway 10, Anytown. My thinking is that announcing my tail number just eats up radio time, and almost nobody can read my tail number anyway. Is that reasonable?
So this is another really great question. I think one of the things that I encourage students in our local area to do is, we have 442 Bravo Golf, 282 Bravo Golf, 332 Bravo Golf. So we're pretty particular about using a full and proper call sign. The other thing that I would do is, instead of saying November 442 Bravo Golf, I would say Seminole 442 Bravo Golf. Because if I do that, it really, as Ethan said in the presentation, it alludes to, you now can characterize the rate of closure that I may have with you, especially if we're head on and we're two Seminoles approaching it, 3 miles a minute each. Or if you're the Cessna 152 out there and you're on downwind, and we have a Seminole coming up behind, if we were to say, Piper Warrior or Warrior 282 Bravo Golf versus Seminole 442 Bravo Golf, I think it's quite helpful. So, you are right. The tail number is important if we're trying to figure out who's out there, but the label, is important to know what kind of speed and performance capabilities we're looking at. If I'm going to go around and I know I'm in a Seminole that day and I know that the Warrior beneath me is, on their final approach and our closure is not good, I know I'm probably gonna be able to outclimb them. So again, the performance consideration is there. The other thing with the tail number is a lot of your ADS-B or traffic equipped aircraft have the capability to put a tail number, a screen on that shows the actual tail number of the aircraft. And so that's the screen I typically run on. Is I really like to see the tail number along with the target. So now I can start associating where that aircraft said they were going to be, and it really helps me paint a much greater situational awareness piece. So for me, I tend to say Seminole 442 Bravo Golf because I think it's very helpful in understanding performance capability. Do you have anything else that you want to add to that?
No, I think, like I was talking about earlier, frequency congestion, you bring up a really good point of, am I just adding to the congestion if I'm saying my tail number? I completely agree with everything that Kathy's saying, where if you think it's going to benefit the whole, leave that tail number out and just talk about your aircraft type, because it gives everyone that better awareness of who they're looking for or what type of aircraft they're looking for. Because, they're probably not trying to say, 442 Bravo Golf, I know who's in there, so I'll talk to them afterwards. Not necessarily what the goal is. We're just trying to keep that separation in the pattern. So I agree with what Kat said.
From Jim, what is your opinion of midfield crossings at pattern altitude to join downwind?
Yeah, so I actually, in that advisory circular that I mentioned earlier, this is the secondary way that the FAA encourages entering the traffic pattern. I think that if you're in an empty traffic pattern or there's only one or two other aircraft operating, then that's a perfectly fine and legal way to enter the traffic pattern. However, if you're in a congested pattern and you know that there are 4, 5, 6 aircraft operating in that vicinity of the airport, overflying the airport and entering that 45 from a different angle allows you to get a better picture of where the other aircraft are, and then ultimately gives the other aircraft a picture of I can look above and I can catch them flying above me and then see them follow along with the 45 downwind behind me or in front of me or something like that. So I think when you start getting into that congestion, overflying is probably your safer bet, and definitely it paints a better situational awareness for that traffic that's already established in the pattern.
Next question from Justin. I may have missed this, but what is your thought on a straight-in approach if you're already lined up from several miles out?
Yeah, again, a very common practice. I think as long as it fits into the traffic pattern, it doesn't quite make sense for you to overfly the field and enter the pattern, as long as you're announcing your intentions. So you say, hey, I'm on a 10-mile final. I recognize that there's other aircraft in the pattern, and I will vary my final approach speed to make sure that my final approach lines up with everyone else who's in the pattern. I don't think that you need to go out of your way just to overfly the field if you're already kind of lined up straight in for that approach.
And I also think one other element of it, I'm going to focus on the flight training piece of it, is if we go to one spectrum where we say all students, all pilots should overfly and enter on the 45, well, then we start to really not prepare our students for the day where they do need to do a straight-in approach, and how do they estimate their descent profile along down and lose an appropriate amount of altitude for a given mile inward that they progress. So I think it's important that we teach our students multiple skill sets. So I do think the straight-in approach is a really critical skill set, and if we don't teach our students that, they are going to have a faulty approach, could have a low approach or an overly high approach, and that could lead them to a faulty landing. So I think it's important. And then Ethan did bring up in the presentation, one thing that we started doing in our environment was we do have quite a few straight-in approaches because our instrument approaches come into all 4 runways at Wood County Airport. So we have an RNAV approach going into runway 18, 36, 10, and 28. So very often you'll see instrument traffic trying to do a straight-in approach while the visual traffic is coming overhead and getting themselves situated on the 45 degree to an entry on the downwind leg. And so it's just a matter of getting that spacing. But one thing we started to do was, especially if we had like the Seminole, and the Seminole was, running 2 engines, your ground speed is going to be different than the day that you're simulating single engine. And that might give people more time or less time. So really just kind of including that speed element was something we adjusted about a year or a year and a half ago to really help that piece of the puzzle as well.
Just reading the next question here. A question from Aaron on the topic of frequency congestion. Do you feel like calls such as runway crossings or announcing taxiing from the ramp to a specific runway are necessary calls on a busy pattern day?
This is a big teaching point for me with my students as well. For example, at 1 Golf 0, if we're taxiing out to runway 28, we are crossing runway 1836 on taxiway Alpha. Making that call that you're departing or you're leaving the ramp for runway 28 or that you're crossing 1836 really isn't that necessary when the pattern is congested. If you feel like you're only going to step on people or you're going to be in the way, don't make that call. Just be very vigilant when you're crossing that runway, or even just any of the taxiways, to make sure that there's no other traffic on the ground that may be towards you, or maybe landing or a low approach on that runway that you're crossing. Ultimately, again, airport diagrams and just looking outside, looking down the taxiway, looking at the departure ends and the approach ends of the runway where other traffic may be on the ground, and seeing maybe what they're doing is going to be key, because you do have that radio, the opportunity on the radio to announce your intentions or to talk. But if someone else is on the radio or there's a congested pattern, maybe skipping that call as long as you can verify visually that there's not going to be any other implications while you're taxiing.
Sweet. Next question from Michael. I fly an experimental, so I announce experimental in the last 3 of my N number. Problem is, an experimental can be anything, and very few GA pilots know specific experimental models and their speeds. Any thoughts on this in the pattern?
I'll take that one. I think that brings up a really good point. And it could be an experimental. It could just be that a student isn't even familiar with the type of aircraft that is coming in. Maybe it's not something they've heard of before. So in that case, I think I would fall back to what I said in my previous comment, which is sometimes being able to say, if you're an experimental, but you're a high performance experimental, maybe it's saying, I'm on the downwind and ground speed right now, I'm doing 130 knots or something like that. Maybe being able to infer the performance capability of the aircraft could help those around you know the element of time that they have to make their decisions. And then, it could just go back to that plain talk again, is, if you feel like people don't understand and they're assuming that you're an experimental that maybe doesn't have capabilities that you do, it's just being able to open up the dialogue and say, hey, I'm gonna beam the numbers and I'm gonna make a short approach, or, or inferring your speed as well. So I would just use descriptors that kind of help the element of performance and speed come out in the communication.
Yeah, and to add to that one really quick, human talk is key. I tell my students, and a lot of students probably think that they have to be really cool and have to use all the aviation lingo all the time just to make themselves sound like that cool pilot. That's not the case. If it's a matter of safety, and like Kathy said, if someone else in the pattern isn't understanding your intentions or your type of aircraft, using that plain talk, hey, I'm a white and green experimental aircraft, I'm doing 160 knots across the ground, I've got that other traffic in sight, or hey, student pilot that just called departing, I'd maybe wait a second because I'm doing a lot faster ground speed than you think I am. That human talk is key to that situation awareness, especially in a high volume of flight training, where we have those student pilots that don't have that experience in the general GA community.
Next question from Brad. I've seen pilots overfly the field and turn directly 90 degrees onto the downwind without a teardrop type entry. Is this legal?
Yeah, this is, we kind of answered this question a little bit earlier. This is perfectly legal. There's nothing in the regulations or in the AIM or in the advisory circular that says it's not. However, when you do just overfly the field at traffic pattern altitude and enter that downwind on a 90-degree angle, you're not allowing yourself that extra time to get the aircraft configured or to get that spacing between other aircraft that might already be established in the pattern. So if you're going into an uncontrolled field and you're the only person that operates out of that field, then there's nothing wrong with that. You just have to be aware of who else is operating in the vicinity of that airport.
And I also think we'll kind of get into one of my, I guess you could call it a pet peeve. It's an area of concern is the high wing, low wing scenario as well. So if you have, an airport where you know that there's Cessna and Piper models, you're talking high wing, low wing for an example, typical training environment, having that Piper come in and teardrop onto the 45 and descend onto it or descend onto the downwind is a pretty dangerous thing if we're running, if there's other high wings running there that they're not going to see, and we're going to have two aircraft that could have a loss of separation just due to blind spots. And so I think it's really important to go out, get out away from the traffic pattern, descend, and then enter level on that 45-degree entry. And as Ethan, recommended, pointing maybe at the opposite end of the runway that you're going to make the landing on, so you actually can establish a proper downwind and really survey the scene and keep your eyes open for what traffic is talking. And then, there might be folks that don't have electrical systems, they aren't talking, and or maybe just are distracted and don't see or hear you. So I think that's another really important strategy that you could use.
That was the last question. Any final comments before I talk about maybe future safety series?
No, I think Ethan and I just want to say thank you so much. Your questions are incredibly relevant. I think that right now traffic pattern safety is more critical than ever. The volume of aircraft in the training environments or even in our local GA airport environments is definitely on the uptick. And I think that places a really great responsibility on each and every one of us. So see and avoid and communicate effectively, and just realize that you just never know what's going on in somebody else's cockpit. So you really need to think about being able to observe the scene and appropriately react. So thank you all for your time and your questions this evening. They were fantastic.
So you might not heard me early on, but this was the second safety workshop that we've done. We did one earlier in the springtime. The camera will focus on me here in a minute. There we go. But we did one back in the springtime on loss of separation. I will drop the link into the chat when I'm done talking here. We do plan to continue to do these safety workshops into the near future. We've partnered up with the FAST team to ensure that those safety workshops are promoted to the flying community here in the region. I think a lot of what we do here at BGSU is definitely relevant to the GA flying community, and that's why we want to share these workshops with you. Now, it's been our goal to do a workshop, primarily one a semester in the role of higher education. We primarily have 3 semesters, so we did a spring safety workshop. This is our summer safety workshop, and then we plan on doing one in the fall. The fall date and the topic hasn't been set yet. We look at safety data to determine the topic, so as we get more safety data throughout the summer and as we go into the fall, we'll make a decision on what type of topic to do that presentation on. Also, I'm really hopeful that hopefully we can have an in-person element to the next safety workshop. We have a wonderful airport here in Bowling Green, Ohio. It's located on campus at BGSU, so it is a relatively easy walk to get to whatever location we're hosting this next workshop, either on campus or at the Bowling Green Flight Center, which is right on airport. And again, we'll promote that out when we know that information. But even if we can't do an in-person seminar down the road, we still plan to offer some type of virtual attendance because we know not everybody has the option, or maybe their schedule doesn't permit them to come over to Bowling Green to join us. So again, be on the lookout for that. Other than that, thank you for joining us this evening. Appreciate your time, and hopefully we'll see you down the road. Have a great night, y'all.